Welcome to the Chemistry Learning Channel. I'm very excited to share my passion of chemistry with you, and I hope you'll enjoy this video. In this video, I will be talking about balancing chemical reactions, and I will be working 4 example problems. In this slide, I will be working this balancing chemical reaction. So balance the reaction when propane C3H8 burns in air to form CO2 and H2O. So first, we'll start off with the unbalanced chemical equation, which is C3H8 plus O2 gives yield to CO2 and H2O. So first, to balance this equation, we'll start off by balancing the most complex molecule in this reaction, which is this propane. And in order to balance the equation, we'll count the atoms on the reactant side, which is here, and then we'll also count the atoms on the product side. And then we will try to balance the C and the H first. So first, to start off balancing the reactant side, we'll count the atoms. So we have H, O, and C on the reactant side. So we have 8H because this subscript means that there are 8 H atoms. And so for oxygen, there are 2 because oxygen is the only one that has it here. And then for C, there are 3 atoms because this propane has the subscript of 3 for carbon. And similarly, we'll do it on the product side. So we have H, which comes from the H2O. The subscript 2 means we have 2 hydrogens. And then for oxygen, we have 3 because in CO2, oxygen has a subscript of 2, which means that there are 2. And then for H2O, there's 1 oxygen. So if we do 2 plus 1, we get 3. And then for carbon, in the CO2, there's only 1 carbon. So we'll put the 1 here. So as we can see, in order to balance our most complex molecule, which is C3H8, we have to balance the carbons and the hydrogens first. So we see that there's 8 on the reactant side and 2 on the product side. So we'll put a 4 in front of the H2O. So 4 will be the coefficient, which will multiply the 2 into 8. And then for the carbon, we'll put a 3 in front of CO2 in order to make this 3. And then I will work this out on the next slide. So like I said previously, we put the 3 and the 4 here, and if we do that, we get the hydrogens to be balanced because now the reactant side has 8 and the product side has 8 because when we have a 4 as a coefficient, we multiply it by the number of atoms here. Since there are now 4 molecules of water, we have 8 hydrogen atoms. So the coefficient multiplies the number of atoms in the subscript here. And then for carbon, we also did a similar thing where carbon just has a 1 as the subscript. So since we have 3 molecules of CO2, we now have 3 carbon atoms. As we can see, we now have the hydrogen and carbons balanced. Now we just need the oxygen to be balanced. As we can see here, there's 2 oxygens on the reactant side here, and then there's 10 oxygens on the product side. So the easiest way to balance this is if we multiply this 2 by 5 in order to get 10. And in order to do that, if we put a 5 as the coefficient in front of this O2, we'll get 10 atoms of oxygen. And I'll show that on the next slide. As you can see, when we put a 5 in front of the O2, we now have 10 oxygen atoms and 10 oxygen atoms on the product side. And now we have a perfectly balanced chemical equation. And this is our answer. This is the final solution. This next problem is balancing this chemical equation. So we have iron and oxygen gives yield to iron oxide. So in order to balance this, we'll first start off by counting the number of iron and oxygen atoms on the reactant side, and then iron and oxygen on the product side. So first, starting with the reactants, we have 1 iron, so we write 1, and then we have 2 oxygen because the subscript 2 right here means we have 2 of that atom. And then on the product side, we'll do the same thing. So since the subscript is 2, we'll put 2 iron here, and then there's only 3 oxygens, so we'll put 3 here. And then, so as we can see, in order to balance the most complex molecule here, we'll have to adjust to balance the iron and the oxygen. In order to balance this equation, we will put a 4 in front of iron, and then 3 is the coefficient for oxygen, and then 2 is the coefficient for iron oxide. So this balances because, as we can see, we have 4 iron on the reactant side, we have 6 oxygen because the 2, and then we have 3 molecules of that O2, which means we have a total of 6 oxygens. And then for the product side, we have 2 molecules of iron oxide, which means we have 4 iron since there's 2 multiplied by 2. And then for oxygen, we have 3 multiplied by 2, which gives us 6. And so the reactants equal the products, and thus we have a balanced chemical equation. In this problem, we will be balancing rubidium plus rubidium nitrate gives yield to rubidium oxide plus nitrogen. This is a little bit of a tricky problem, and we'll have to go through multiple steps. But first, we'll start off with counting the atoms of reactant and the number of products. So we have rubidium on the reactant side, and we have 2 atoms because we have 1 here and then we have 1 here, which gives us 2. And then for oxygen, we have 3 because the subscript 3 denotes that there are 3 atoms. And then for nitrogen, we only see it here, so it's just 1. And then for the product side, if we do the similar, we see rubidium has a subscript 2 here, so we have 2 atoms. And then for oxygen, we have just this one O here, which gives us 1. And then for nitrogen, we have 2 from the subscript 2 here. As we can see, it's not a balanced equation, and then for the next step, we'll balance it. First, we'll start off by balancing the most complex molecule in this equation, which is this rubidium nitrate here, and we'll start off by balancing the nitrogen part, since it looks the simplest. So first, if we put 2 as a coefficient here, we get the number of rubidium to be 3 because we're multiplying this by 2, and then we're adding 1 here, so that totals to 3. And then for oxygen, since we have 3 oxygen here, but we have 2 molecules, there's going to be 6 here. And then for nitrogen here, it becomes 2, since there's 2 molecules entirely. As we can see, we now have the nitrogen balanced. And then next, we will balance the oxygen in here. So to balance the oxygen, since we have 6 oxygens, we need 6 on the product side. In order to obtain 6 oxygen, if we put 6 in front of the rubidium oxide, we'll get 6 oxygen here. And so now we have the oxygen and nitrogen balanced. And lastly, we'll balance the rubidium. As we saw on the previous side, we have 12 rubidium. So in order for the reactant to also equal 12, we have put 10 as the coefficient here. If we do that, we now have 10 rubidium plus 2 rubidium, which gives us 12 rubidium. And this makes it match the products, and we have a fully balanced chemical equation. Thank you for watching. If you liked it, subscribe, like, and share this video.